Alright, here are a few preliminary things that we need to go over before we get started. First of all, we have this guy called n factorial. It's just n exclamation mark, n permutate k, and n choose k. That's what this section is about. So n factorial, you may remember, to be just the product of the first n positive integers. Okay, and this actually equals the number of ways to arrange or permutate n items in order from left to right. The number of ways to choose and arrange k items from n items, that is, to choose and arrange k items from n items, is this guy. Okay, and again, we read this as n permutate k. A funny little notation with subscripts on both left and right side of the p there. And finally, n choose k is sometimes written like this, n c k, but we'll always write it like this. Usually, at least, maybe always, write it like this. This is a more standard notation, I think. It looks like a fraction, but it's not. There's no fraction bar in there. This thing is defined to be n factorial over k factorial, n minus k factorial. This is just the number of ways to choose k things from n things. So, for example, let's suppose that you're getting ready to take a trip, and you've got 10 CDs that you're going to take. You can do, if you remember what CDs are, compact discs, right? You can listen to these in any order. The number of ways to listen to all 10 CDs, and you listen to, let's say, each one exactly one time, is 10 factorial. Now, I am going to use my calculator on this, if I can find it. Well, can't find the one I wanted, but we'll do it the old-fashioned way here, okay? 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Whoa, that's 3,628,800. Okay, that's a lot. These numbers get really big, really fast. Okay. How about what if you have 10 CDs, but maybe you only want to choose and listen to 5 of them? How many ways can you pick 5 CDs from the 10 and then listen to those in different arrangements, different orders? That's going to be 10 permutate 5. Okay, and that's by the definition there, it's going to be 10 factorial over 10 minus 5 factorial, or 10 factorial divided by 5 factorial, or, you know what, this is just 10 times 9 times 8 times 7 times 6, isn't it? Because the 5 factorial cancels with the 1 times 2 times 3 times 4 times 5 in the top. So this is just 10 times 9 times 8 times 7 times 6. 30,240. Okay, and it's a lot less. Okay, it's a lot less. What if we're interested in knowing the number of ways to choose 5 from the 10? We don't care what order that we're going to put these in from left to right, but just how many different subsets of size 5 are there? You can think of this as how many, the same question would be how many different samples of size 5 are there from the 10? Okay, so this is 10 factorial over 10 minus 5 factorial times 5 factorial. Hey, you know what? This is, in fact, it's just the same thing as 10 permutate 5 divided by 5 factorial, isn't it? So you can see that these formulas are all related. So it's just the previous answer divided by 5, and then divided by 4, then divided by 3, divided by 2, divided by 1. 252. It's much less. makes perfect sense, okay, that in the way that these two are related, right? Because here, in this case, you're just concerned with the number of ways you can actually just simply choose the 5 things from the 10 things, and the order doesn't matter. But once you actually choose the 5 things, if suddenly the order matters to you, then there are going to be 5 factorial ways to arrange those things in order. So this answer up here should be 5 factorial times this answer down here. Okay.